Okay, so in this question, we're going to first of all show that the points P and Q are both on the line with that equation. All right. Now, this is quite straightforward. We're going to start by rearranging this equation, actually, just to put it in a different form. And we're going to simply add y to both sides and take away 3. So we can write it as y equals 2x minus 3. All right. And now we're going to substitute the coordinates for P in and show that it works. So when x equals 4, so for point P, okay, so if I put here question A, so for point P, we've got that y equals 2 times 4 minus 3. 2 times 4 is 8 minus 3, which equals 5. Okay, so it works for that. Okay, therefore, for 5 is on the line. Okay, and now I do the same thing for the point Q. Okay, y equals 2 lots of, well, the x coordinate of the point Q is 1. Okay, take away 3. And that equals 2 take away 3, which is minus 1. And that is indeed the y coordinate. So therefore, the point 1 minus 1 is on the line. Okay, that's it. Right. Part B, I'm given a third point, 10, 2, and I've got to find the equation of the line PR, okay, and explain why triangle PQR is right angled. Okay, so the line PR is this line here, which continues on through the x-axis. I could actually just draw the line in just to show where it would be. Okay, so the line PR is going to be the line that goes through R here, goes through P, and continues off that way somewhere. Okay, and we want to find the equation of that line. Now, we can't just read it off the graph. It looks like it's crossing at 7, but we need to show that. Okay, so the first thing I need is the gradient. So I'm going to show you how to do this here. So for part B, let's do it here. Okay, so the gradient of PR is the change in y divided by the change in x. So if I take the points P and R, okay, subtract the y coordinates, okay, and then divide it by the change in x. Well, I must do them in the same order. So I did 5 take away 2. I must do 4 take away 10. Okay. Now that gives me 3 over negative 6. Okay, which cancels to negative a half. That's the gradient. All right. So the equation of PR, the equation of the line, which is what I want, equation of PR is equal to y equals minus a half x plus some constant c, which is where it cuts the y-axis. So y equals the gradient times x plus c. Now, we know that one of the points P, we know that P and R are both on the line. So if we took one of those points and substituted its x and y coordinates into this equation, we would find C. So substitute x, y with 4, 5. Okay, that's one of the points. All right, and I get this, don't I? I get 5 equals minus a half of 4 plus c. Okay, so I'm just replacing the y with 5 and the x with 4, you see. And if I work that out, I get 5 equals minus 2 plus c, and therefore c equals 7. And we said we thought it was 7 from this graph, but that's proof that it is. So the equation of PR is y equals minus a half x plus 7. Okay. Right. Now, the next thing I have to do is explain why it's right-angled. Well, PQR is right-angled because PR, okay, the line PR is perpendicular, okay, that means at right angles, perpendicular to PQ. And the reason I can say that is because, or since, minus a half times 2 equals minus 1. In other words, the gradients are the negative reciprocal of each other. Okay, so the negative reciprocal of 2 is negative a half. Okay, so PR is perpendicular to PQ since the product of the gradients is negative 1. That's another way of saying that one gradient is perpendicular to the other, okay, or is the negative reciprocal of the other. So that would do for your answer. That's mathematically sound. Okay, so therefore triangle PQR is right-angled because we've shown that there's at least one, well, there's one right angle in it. There can't be at least one right angle, there can only be one, otherwise it wouldn't be a triangle. Okay, right, okay, and finally the area of the triangle. Well, if I just quickly sketch the triangle in, if I take out, if I just finish off the lines that make the triangle up, I'll do them in a different colour. No, I'll do them in green. Okay, so the lines that make the triangle up are this line here, this line here, which I'll go over in green, and this line here. Okay, the best way to find the area of that triangle, just ignore the rest of that line there. In fact, I can just take it out. Okay, the best way to find the area is to put a box around the whole thing, okay, like this. And I can easily work out the area of the box. That is going to be a height of 6 and a length across the bottom of 9. All right, so that's got an area of 54, 6 times 9. And all I do is subtract the area of the 3 right-angled triangles that I just made. Okay, if I just quickly shade those areas in, if I find the area of that, the area of this, and the area of this one, and subtract those 3 areas from the box area, that will give me the area of the triangle PQR that's left in the middle. All right, so it's a really simple technique. I'll do this quite quickly for you. It's quite easy to see what's going on here. So if I took this triangle here, it's got a length of 3 along there and a height of 1, 2, 3, 4, 5, 6 Okay, so that's 3 times 6 is 18. Half of base times height is half of 18, which is 9. Okay, you'll find that this one is also 6 by 3, so that also has an area of 9, half of 18. And this triangle at the bottom has a base of 9. That's going from 1 to 10, you see, that's 9, and a height of 6. Okay, so sorry, a height of 3. 9 times 3 is 27. Half of 27 is 13.5. Okay, so the three numbers I've written in circles are the areas of those three triangles. So the total area, so for C, okay, area PQR equals 54, which I got from 6 times 9, minus 9, and the other 9, and the 13.5. Okay, so those are the three areas. I don't know if you can hear the tractor going by, but that's what that noise is. Right, okay, so let's just work it out. 54, take away 18 plus 13.5, that's 31.5. Okay, well, 54 take away 30 is 24, take away another 1.5 is 22.5. 22.5. And you can't say that it's in any particular units. You can say units squared, okay, but we don't know what the units are. They may be centimeters, they may be something else. So we don't need to actually do that. We'll just get away with the number, but units squared. Okay, and that's the area of the triangle PQR.